Okay, so this question says the same load is being hung from each construct, which we can refer to as W in both cases, and each construct is made up of springs with the same length and stiffness. So if we choose two springs, one from either construct, say that one in A and this one in B, again, same length, same stiffness, which means these are effectively identical springs, and we can treat them the same. And then it says, in which construct will the spring extensions be longer? A, B, or if equal, mark C. And the key difference between the two is that construct A uses 2 springs in parallel, where construct B uses 4 springs in parallel. And again, we're talking about constructs made of the same springs, and we're talking about the same load W. So in B, that load will be distributed across 4 springs instead of 2, and therefore each spring will extend less than that of A. But another way to think about it is in terms of Hooke's law, and Hooke's law describes the force that's required to stretch or compress a spring. And that force F is equal to K, the spring constant, times X, the displacement. And that spring constant K is a reflection of how difficult it is to stretch or compress the spring. And the larger the spring constant, the more difficult. X is the displacement. So that's the amount that the spring has been stretched or compressed. So if we were to write the spring constant for both constructs, starting with A, again, we know the spring constant for a single spring is K. So if there are 2 springs in A, the spring constant is 2K. Likewise, for B, we know single spring constant is K. There are 4 springs in B, so therefore the spring constant is 4K. So this is a 2x increase in the spring constant, which is indicative of how difficult it will be to stretch or compress that system. So returning to the question, in which construct will spring extensions be longer? The answer is A.